Hello everyone and welcome to the video lessons for Chapter 8 of the Foundations of Scalable Systems. And in this set of lessons we're going to delve into the weird and wonderful world of serverless computing platforms. Scalable systems experience widely varying patterns of usage. For some applications, the load may be high during business hours and low or non-existent during non-business hours. Other applications, for example, an online concert ticket sales system, might have low background traffic 99% of the time, but when tickets for a major series of shows are released, such as the recent Taylor Swift shows, the demand can spike by 10,000 times the average load for a number of hours before dropping down to normal levels. Elastic load balancing, as I described in Chapter 5, is one approach for handling these spikes. Another is serverless computing, which I'll examine in this chapter. The recent transition of major organizational IT systems from on-premise to public cloud platform deployments seems inexorable. Organizations from startups to government agencies to multinationals see clouds as digital transformation platforms and a foundational technology to improve business continuity. Monthly cloud bills, though, can be big, sometimes really big. Even worse, unexpectedly big. Cases of sticker shock for significant cloud overspend are rife. In one survey, 69% of respondents regularly overspent on their cloud budget by more than 25%. In one well-known case, $500K was spent on an Azure task before it was even noticed. Reasons attributed to overspending are many, including a lack of deployment of autoscaling solutions, poor long-term capacity planning, and inadequate exploitation of cloud architectures, leading to bloated system footprints. Traditionally, cloud applications have been deployed on an infrastructure such as an infrastructure as a service, an IaaS platform, utilizing virtual machines. In this case, you pay for the resources you deploy, regardless of how highly utilized they are. If load increases, elastic applications can spin up new virtual machines to increase capacity, typically using cloud-provided load balancing services. Your costs are essentially proportional to the type of virtual machines you choose, the duration for which they are deployed, and the amount of data the application stores and transits. Of course, this approach places the burden on you as the system owner to do things like ongoing monitoring and management of the system. You've got to apply operating system upgrades, you've got to look after the security systems, etc. So you're basically doing all of the system administration that's required. When you need to scale up the system, you need to add the necessary capacity. You also have the potential for unused resources, and these of course just chew up costs if you're not careful and don't manage your system correctly. So there are downsides to VM-based cloud applications, basically the effort that you have to expend and the costs that can be incurred to manage the virtual infrastructure that you create. This is where the topic of this video lesson, serverless processing systems, enters the scene. Major cloud providers have offered this as an alternative to explicitly provisioning virtual processing resources. Serverless platforms do not require compute resources to be statically provisioned. Using technologies such as AWS Lambda or Google App Engine, GAE, the application code is loaded and executed on demand when requests arrive. If there's no active requests, there's essentially no resources in use and no charges to be met. Serverless processing platforms also manage autoscaling up and down for you, just automatically. As simultaneous requests arrive, additional processing capacity is created to handle these requests and ideally provide consistently low response times. When request loads drop off, additional processing capacity is decommissioned and no charges are incurred. As this slide depicts, every serverless platform implementation varies in details. For example, a limited number of mainstream programming languages and application server frameworks are typically supported, and these are different by each framework. Platforms also provide multiple configuration settings that can be used to balance performance, scalability, and cost. And again, these vary across platforms. So you really have to delve in deeply to your serverless platform of choice to get the best value and performance and scalability out of it. Of course, while serverless platforms have many advantages, there is no free lunch. There's always trade-offs that you have to consider. Let's look at some of these. In general, serverless platforms force your applications to be designed as stateless. This enables the serverless platform to make effective load balancing decisions on your behalf and also manage the platform across multiple competing services. Also, there's normally a maximum duration on the invocation for a single function. It varies from platform to platform, but you'll see things in the range of 60 to 300 seconds. After that, the platform times out an invocation with an error. There's also lots of parameter settings that you can use to control how long it takes and how often individual instances are started. You can specify that there are, for example, always a small number of instances ready, so that when a request arrives, there's always a resident server instance to handle that process. This alleviates the problem of cold starts. Cold starts occur when there's no processing available for your service. Basically, your code isn't loaded anywhere, and you have to pay the cost of loading the code into the system, which can vary dramatically across languages depending on the runtime environment and the libraries you choose. Also, you have to pay attention to the charging model. Each platform charges you differently for application usage. I'm not going to delve into the details here on this slide, but you can see that basically different platforms will charge you different rates for different features that you utilize in the system. So the devil lurks as usual in the details. So in the rest of this chapter, I'm going to explore some of those devilish details specifically for Google App Engine and the AWS Lambda serverless platforms. So next is a deep dive into Google App Engine. Thanks for watching.